So we've talked about the three different methods of heat transfer: conduction, convection and radiation. The last little part of this is about heat transfer by evaporation. This is probably the hardest part to understand because we have to try and get a particle model to explain this properly. So you'll know, I'm sure, that sweating is a way of cooling the body down. Here's an example of two people. Here's somebody in a desert doing loads of exercise, and this guy doesn't look very sweaty. Okay, here's a lady in a jungle who's not been doing much, but she's absolutely covered in sweat. Okay, who's actually at most danger? What's going to kill these people? Well, interestingly, the lady might be in danger of dying from her body temperature increasing too much, whereas the man is only actually in danger of dying from dehydration. The sweat is coming out of both of their bodies, but the reason the guy is going to be okay in terms of his body temperature is that the sweat is evaporating. The danger in the jungle is that the sweat doesn't evaporate because there's so much moisture in the air, and that's why you overheat. Okay, so we can show this with a little investigation. You'll have done this practical. What you do is you get some thermometers and you cover them in cotton wool, and then you soak the cotton wool, one in water, one in ethanol, and then one you just leave dry, and then you measure what happens to the temperature over time. So every 10 minutes you record the temperature every minute for 10 minutes, and you see which one cools down the most. Okay, it's interesting really they cool down at all because they're already at room temperature. The ethanol and the water are at room temperature, and yet somehow they cool down. Okay, so our task really in this lesson is to understand why it is that just soaking something, even though the stuff that you're soaking in it is the same temperature as the surroundings, why would soaking something in water or in ethanol make it cool down? Okay, well, what we find is that the ethanol one cools down, and the reason for this is what's going on in the particles. So here's our little animation of diagrams of the particles in a liquid. Okay, they've not quite filled in the space because it's a bit tricky with the animation, but here's our particles in a liquid. Okay, but of course they're not stationary. The particles in a liquid are free to move around even though they collide with each other. Okay, at a certain temperature, okay, not all the particles have the same speed. So if you look at them here, they're moving around, but some of them are moving fairly slowly, some of them are moving much faster. If we heated the water up, the average temperature would increase, okay, but we'd still have some going faster than others. Okay, so what happens when it evaporates is, well, which one of these particles is most likely to manage to evaporate, to escape from the liquid? The answer is the one that's going fastest. Okay, so the fastest one whizzes off and escapes. Okay, what does that do? Well, it lowers the average speed of the ones that are left. Okay, in the same way the temperature controls the speed is just linked to the temperature. Okay, so if they're going slower, then the liquid overall is cooler. Okay, again, another one can escape, another one can escape, and the ones that have got the least energy, the slowest moving ones, are the ones left behind. So the water ends up cooling down, or in the case of the ethanol, obviously the same thing applies to the ethanol. The ethanol cools the thermometer down faster just because it's easier for the particles to escape, so it escapes faster. Okay, I'm sure some of you will have like wipes on your hands sometimes for like before injections. They feel cold. They feel cold because the particles are evaporating, and that makes the temperature drop, and that sucks more heat out of your skin. Okay, so here's our stages. You need to be able to describe these stages. So there's a range of energies of the particles in a liquid, okay? Even though the liquid is one temperature, the particles in that liquid have a range of different energies. Okay, so there's some of the ones seem to be, it's as if they're hotter than others. Okay, it's the particles with the most energy that can escape, okay, evaporate from the liquid surface. And if you lose the ones with the most energy, then the average energy will decrease. Okay, if the average energy decreases, that means the temperature of the liquid left behind is lower. Okay, so this is how things cool down because of evaporation.